Hello everyone. I hope that you are fine and well. Today I'm going to continue the next topic of the chapter coordination compound of class 12, and that is homoleptic and heteroleptic complexes. So about the homoleptic complexes, the complexes in which a metal is bound to only one kinds of ligands. It means those type of complexes in which only one kind of ligands is attached, that is known as homoleptic ligands, like Cu NH3 whole 6 plus 3. So here only NH3 ammonia ligand, amine ligand is attached to the cobalt. Here again Cr NH3 whole 6 plus 3. So here again the amine NH3 ligands is attached to the chromium. Here the cyanide ligands is attached to the iron in FeCN6 minus 3. PdCl4 minus 2, in which the Cl 4Cl ligand is attached to the palladium. Again HgI4, here the 4 iodine ligands are attached to the mercury. CuNH3 whole 4 plus 2. So here the 4 ammonia ligands are attached to the copper. So these coordination compounds or complexes are known as the homoleptic complexes. Now the heteroleptic complexes, so those complexes in which a metal is bound to more than one kinds of donor group. So it means when the different types of ligands are attached to the central atom in a coordination compounds, that is known as the homoleptic complexes, heteroleptic complexes. Okay, so here is the example COEN whole twice Cl2 plus. So here is the En ethylene diamine and the chloride. Both are different ligands attached to the central metal cobalt, and here again CrNH3 whole 4 Cl2 plus. So here NH3 and Cl2 are the different ligands attached to the central atom. Again FeH2O whole 4 C2O4. So here the oxalate and H2O group ligands are attached to the iron. Iron means the central atom. Again CuNH3 whole 4 Cl2 plus. So here the amine ammonia and chloride, both are the different ligands which is attached to the cobalt. So these complexes are known as the heteroleptic complexes. It's clear? So in simple way I can say that those the complexes in which the same kind of ligands are attached, so they are homoleptic, and when the different type of ligands are attached to the central atom, that is known as the heteroleptic complexes. It's clear to all of you. Now the next topic is nomenclature of coordination compounds. How we can give the name to the coordination compound. So for it, the International Union of Pure and Applied Chemistry, which is IPSC, published rules for the systematic naming of coordination compound in 1957. So when the lots of coordination compounds are discovered, then IPSC, which is an organization, so in 1957 he gave the systematic rule for the naming of the coordination compound. Some modifications in these rules were made in 1962 and 1970 one. So in 1962 and 1971, they have they did the some modification about the rules of the coordination compounds. However, tribal names of certain complex compounds are still in use. Some compounds which is named before are called the same name at this present time, like K4FeCN6, which is known as potassium ferrocyanide, and K3FeCN6, which is known as potassium ferricyanide. So here it is pronounced or named ferrocyanide, and here it is known as the ferricyanide when here K3. Okay, so when here K3 is attached to the to this coordination entity, then it is known as the potassium ferricyanide, and when it is K4 attached to the coordination entity, then it is known as potassium ferrocyanide. Okay, so formulas of nomenclature, formula of mononuclear coordination entities. So how we formulate for the mononuclear coordination entity. Mononuclear coordination entity contain a single metal atom. Okay, so mononuclear coordination entity has only one single atom, single metal atom. So how can we write the rule, or how can we write the formula of this compound? So the central atom is listed first. So firstly we will list to the central atom. The ligands are listed in alphabetical order. So whatever the ligands are attached with the central atom, we will give the name of them in alphabetical order. Polydentate ligands are also listed alphabetically. If polydentate ligands are attached to the central metal, then it is also named in alphabetical order. And in case of abbreviated ligands, first letter of the abbreviation is used to determine position of ligands alphabetically, like ENOX. So firstly, the abbreviated form we will be use En and OX. Oxalate we will use the OX. Ethylene diamine we will use the En. Formula of coordination entity is written in square bracket. So the coordination entity which is in the square bracket. So we will write the coordination entity formula in a square bracket like this. Next is formula of polyatomic ligands are also written in parenthesis, means in bracket. Ligands abbreviations are also enclosed in parenthesis. So whatever the polyatomic ligands, their name is always written in a bracket, and the ligands is also named in the abbreviation form in a bracket. There should be no space between ligands and metal in coordination sphere. So we should not give any spaces between the ligands and metal when we will write the formula in a coordination sphere. Charge on coordination entity is written when it is without counter ion. If there is no counter ion, so always we will write the charge, whole charge on that complex compound. The charge indicates outside bracket as a superscript with the numbers before the sign. So whatever the charge will be produced without the counter ion, we will write it in a superscript before the sign. So it means firstly we will write the digit and then we will write the sign minus or plus. Okay, so here I have written an example COCN6 and 3 minus. We will not write minus 3, that will be the wrong way according to the IPSC. Firstly we will write the digit and then we will write the sign 3 minus or plus. Okay, next rule is the charge of cation is balanced by anions. So we will always balance the charge of cation and anions, like CrH2O whole 6 3 plus, CONH3 whole 4 Cl2 plus, and COEN whole thrice 3 plus. So we will always, whatever the counter ion has the charge, we will write the opposite charge on this coordination entity, above the coordination entity. It's clear? I hope that you have understood this. In my next video I will teach you the next topic about the nomenclature of the coordination compound. So thanks and have a good day.